Welcome to Haxby Shed and part 10 of servicing this Harrison universal milling machine. Now in this part, we take this motor off, get the bearings out, fit new bearings, put a new seal in the base of this gearbox and run a few simple tests. We're almost ready to start milling. Now the milling is in the next video, but as a teaser I've put a little bit in to start this one. I hope you find it useful. You can hear how quiet that machine is now. I've just sped the spindle up a little bit. It was probably only about 45 RPM and I was aiming for 65. So I just wound it up a little bit on the speed pot. I'm going to have a look at those table motor bearings. I said I wouldn't do it now, I'd do it offline much later, but I'm waiting for so much stuff coming through the post at the moment, I'm kind of stuck. So I'll get that done, maybe before Christmas. I won't get bearings through the post, but I might be able to get them locally. Anyway, something that has come through the post, these three cutters, 27mm arbor, an 8mm, a 12mm and a 16mm. Do you know the temperature has gone up 15 Celsius in one day. What's that, 25 Fahrenheit? Just overnight. So of course everything is frozen in here still and everything's sweating like crazy. But it's better to be warm than cold, I have to say. Well, they don't make this easy, do they? You can't get that motor out without removing the helical gear on the shaft, and you can't get to that with the motor in place as it should be. There's no direct line without taking this out, and I don't want to do it. So I've had to unscrew the motor and kind of cant it over and then put this piece of plastic in here to lock these gears, and it's just enough to free it off. I hope that gear's going to come off now, because the oil seal must be directly under that. Now there hasn't been any leak. Well, I've taken this selector shaft out, I've taken this gear off, but I've worked out if I can turn that gear, then the bronze helical gear will lift the worm, which is on the end of the shaft of the motor, where I'm pointing to there. Okay, here goes. Now, hopefully the motor won't fall on the floor. It's held by one screw, but only just, because I had to have the motor at an angle to get my Allen key in. Oh, it's lifting it, look. Can you see it there? The gear's coming off and the shaft of the motor's further down inside there. Now it's got a keyway on it. I'm hoping that key on the motor shaft will come out through that seal. If not, I'll also have to get that key out. And I don't know how I'd ever get it back in again from this position. Well, it looks like the oil seal bears onto the bottom end of the helical gear. So I think we'll be able to get that motor out if we can just get that gear off it. Well, here goes. There's only 10mm between the bottom of the motor and this table below. Now there's nothing. Aha, gotcha. Right, let's try this motor, see what it sounds like. Well, sounds rough, doesn't it? So those bearings are going to have to come out. No doubt about that. I think I'll get this off by the front. It's coming. Let's make sure this cover goes on in the same orientation. I don't know whether it matters or not, but I'll put one zip tie through there. Then I'll put another zip tie on that cable, which is kind of obvious actually, but just in case I forget, and you can bear witness on the video. So those two line up. Right. Well, this doesn't want to come all the way through. Something needs to be lined up back here somewhere. So I'll take this back case off. I've put a zip tie on the back here on this grease nipple, and that aligns with this, so everything will go back the same orientation. Yes, I thought so. there's a retaining plate at the back here. It has to come out this way only, which I've unscrewed. Actually, it's just like the design of the main motor. It's what I'm trying to show you is that bit there. Well, I got the bearings off easily enough in the press. 6202s, which is what I thought they would be. 15mm here, 35 I think on the outside. Now on here I did find this spring, which must be from that oil seal. So obviously I didn't do it any good the way I was going at it. So I think what I'll have to do is take that shaft out so that I've got a clear run down to the gear that goes on the top of the motor shaft, and I can get straight into the seal then without going at an angle and messing about. Hopefully I can do this without having to pull any bearings. There's just a shield here that comes off, and I'm hoping it'll just come straight out. The seal for the bottom of the gearbox and the table motor bearings are on their way, allegedly. So I'll get this shaft out here, which will allow me to get the worm back on to the top of the motor shaft. Oh, there's not a gasket behind here. Looks like the seal runs about there. Well, the table motor bearings and a seal have finally arrived. 6202s SKF. The seal is an imperial size seal, R4, which means it's got the steel outer. Let's get on with it. I showed in a previous video how this cable gland had been knocked. It's almost pulled out, look, and it's bent the body of the motor. And I did say I wasn't going to do anything about it at all, but I'm just not happy with it. And actually, this flexible cable screws in here, so there's a joint there. And I'm thinking I can probably risk just removing this if I let this out a bit and see if I can get it in correctly. Now I did look for some kind of unions. I've measured this. It's 3/4 UNF 16. I couldn't get any fittings at all. The only thing I could find were for pressurized oil lines for like oil coolers for cars, and they were very expensive and they weren't the right thing anyway. Now I don't have a 3/4 UNF 16 tap, so if I do anything with this I'm going to have to be careful because I can't re-tap it. And of course there's the wires to worry about and everything else, but I don't like the way in which one or two of these wires are just pressed against the windings here as this is bent over. So I'm going to take the risk and see if I can sort it out somehow. I've tried to reach a sensible compromise. You can see I've had to get the cables out of that flexible hose, and that's been quite a bit of work one way or another. Now I'm happy that this brass piece is not bearing on any of these cables in here, and I've managed to sort of get it over by one thread. It was slipped by two threads at this side. I think now it's only about one. I won't be able to straighten this case without making some kind of former for the outside. That's quite a bit of work, and then getting in to hit it, to bend this piece out into shape is difficult, so that's where we're going to leave it. Look at the bend in this rod. Can you see that? Now that wasn't me, and it doesn't line up with where the case was dented either. I think somebody's had this apart, Well, I'm glad I put these on, because sometime around now I'd be wondering which way round it all goes. I've got the wave washer in. I've got the spring clip on the end of here again. Nearly forgot that. Well, I've got the motor back together and it spins freely enough, but I can't put it back on the gearbox because I can't test it, because I started rewiring the inverters while I was waiting for those bearings. And it's quite a job to put this back on, and I don't want to have to take it off again if there's a problem with it. I don't think there will be, but, you know, why take the risk? Now, do you remember this spring, this round spring, was on there when I took that motor off? Huh. And I thought it had come out of this seal, which I've taken out of the bottom of the gearbox, but it doesn't look like this seal has a spring. Well, either that or it's lost its lip, but I don't think it has, which indicates again, probably somebody's been in here before and left that spring behind somewhere, you know, from the old seal. So the next job has got to be finish rewiring the inverters. Let's get this table motor on. It's been sitting there far too long. This is the old seal. I can see now that there's a hole in the bottom of the gearbox with no shoulder. You would think that this seal somehow would go up against a shoulder, but it doesn't. It's just a plain through hole. So it's only the friction of the seal really just holding it in place. But it does mean that the hole is big enough for this to pass all the way through. So I could put this all together and then just shove it up through the, you know, bottom of the gearbox, jack on the bottom of this motor, and in theory it would push the seal into place. Now the seal, this one seems to be, it's metal, it's got a metal casing, but it's also got this, whatever you call it, rubber outer, plastic outer, whatever. But the one I've got to replace it, look, is just metal. And it's only got a thin edge to it. I'm a bit worried that if I put it together and I use this as a kind of jack to jack the seal in place, I'm probably going to damage this edge. This is coming up from underneath like that, you see. Oops. So I think I'm going to take the cautious approach. But one thing I will do is I'm just going to put a bit of a chamfer on this gear here, on this worm, because that's quite a sharp edge there. You see what I mean? It's just a plain hole in the bottom of that gearbox, and the gear comes up like that. It might have been the way it was done originally, but I'm not happy using that motor as a drift to push the seal up into place, because the motor's too darn heavy, and it's got that heavy cable on it as well that runs back to the machine. I'd rather just use the cautious route. I've looked up into the gearbox and I can see that the open face of that seal, ooh, this is proving a bit hard to push, harder than I would have expected. Hang on, I'm a bit nervous now. I wasn't happy with that. This seal is really tight and it was pulling it over to one side, so I've put in a bit of all thread bar and a plate on the top. I'm just going to tighten it up from above and see if I can draw it in that way. The back edge is going in, but not the front edge. Oh, fiddle. Darn. Maybe a bit of both together might help. I just felt it click there. I put weight under this side where it was sticking down more. Let's see if it'll go now. I'll synchronise the two, turning from above and pushing from the bottom. Well, it's going. It's tight. I wouldn't want to be doing it with that motor, but it is pulling in. Well, it's in there and it sits nicely, but I'm a bit confused because as I tighten the motor up, I'm sure that's going to push that seal up a bit. We'll see. I've rounded off the end of this worm gear now and I've checked that the seal goes over it, no problem. So I'm going to put this down inside and use this to locate the motor before I push the motor up and clamp it up. But I know it's going to push that seal through a bit more. Well, the blooming screws are too short to draw this motor up, so we'll have to jack it a bit more, and I can't get underneath this. I've already put the worm gear on, I don't want to take that off, so I'm going to jack it from under this table. Lateral thinking, that's what we need, guys and ladies. Well, this has proved to be awkward. I think if you were doing this, you'd pull that seal through just a little bit more if you could. But then again, how far do you pull it through? That's the problem. So I've managed to get these screws in here. I've put the jack under the table, so I'm lifting the table a bit. Even lifting this edge of the milling machine with this jack didn't push that seal through. So I've got the screws in, but to get the screws in I had to take the washers off because otherwise they're too darn short. And I think we've got there. Having gone to all the trouble of putting a grease nipple in here that works, I'm now taking it out because of course I put seal bearings in. I don't suppose you can see, but I can see that that seal is pressed about halfway out. So you'd have to have that metal edge on the seal, otherwise if it was rubber I think it probably would just pop out. Strange they've done that because the casting is recessed there. Aha! Stick magnet needed. So I'll have to lock the bronze gear from the outside to tighten this up. I managed to get this screw tight enough by holding this gear. We do have to make a gasket. Darn it. One gasket. It's quite a snug fit, that. There is a little bit of end float on that now. I might have to get thinner gasket paper and do that again. I put this retaining plate on there with this gasket, which is 0.8 millimeters. That gave me too much end float in this, but without a gasket it's clamping the bearings. So I've had to order some more of this paper. This time I'm going to try a 0.3 millimeter gasket. Anyway, the motor's running, that's the thing. .3 mil, and this will be it. I ain't changing it after this. That's perfect now. Harrison do like their gasket paper, don't they? You know, one of the channels I watch is Western Truck and Tractor Repair. A guy, I think his name's Warren, he's in California. He's an independent maintenance guy for tractors and heavy trucks and things like that. And I'm sure I heard him say that on a particular Cummins diesel engine, the injection timing was set by the thickness of the gaskets. And some guy had just, you know, put on any old gasket, and Warren had said, man, you can't do that, you know, it's all timed up by the thickness of those gaskets. It was some story like that. It might not be perfectly true, but that's approximately what he said. It's near enough. Anyway, it's quite an interesting channel. You can just see what his day's been like, really. But those people do work hard. I've decided this is just a dust cover because the oil's never going to splash right up here. And I was worried that these would pull through, which it did with the soft gasket somebody else had put on. But I'm quite happy that paper at 0.5 is okay to tighten this up without pulling that through again. Where did the screws go? Here we are. You realise we're getting pretty close now to running this machine. Well, here's a gotcha. I swapped these two gears over to make the table slower. Obviously I didn't screw that on quite as far as I should have done. Now it looks quite a long way off there, but it was much closer. But what happened is that screw dug in. This was held stationary, started to unwind. And look, can you see that label is trying to push its way off? So if I'd have kept that going, it would have smashed through this. Blimey. I think I can just knock this flat again. I don't believe it's gonna, you know, be a problem. I mean, it looks a bit like it's cracking here. Well, it all starts to become clearer. This is not the first time this has happened. This lock nut thing here was always really tight and the thread was damaged. And now you can see it's partially off, but it's just spinning. So the thread's gone inside, so at least that was a safety feature. It didn't completely bust that case, but it's stripping that thread as a consequence. So it's 3/8 UNF. I'm just trying to die on this lower one. I have measured the thread, I'm sure it is 3/8 UNF. Well, it looks like we're going to get away with it. What a design, eh? So now I do think it's happened before, because that nut was super tight on there, but it's still massively annoying. Well, I've set that on the slowest speed, and I'm going to leave that cover off for now until I get the hang of it and understand it, but I just wonder how many of those covers have been broken like that. Let's get these locking screws trimmed before we have another disaster. See how much to take off. 1.4mm off that one. You know, it has taken quite a bit of thread off in there. I'm not going to do it now, but later I might just TIG that, build it up with a bit of TIG, put it on the welding positioner and just rethread it. At that bottom end, you know, when I say bottom end I mean top end. I think that's doable with a bit of TIG, don't you? Wonderful stuff, TIG. So that is locked, and there's no chance of that catching on that end cover now. Should have been like that from the beginning, Harrison. So, onwards to part 11 and some actual milling. But you'll have to wait.